Okay, so we're still working on graphs of sine and cosine. Remember, our ultimate goal was to add in new periods, phase shifts, and vertical shifts. Right now, all we're doing is changing our period by adding something right next to the x. See that 4 is multiplying the x. And we've changed our amplitude by putting a number in front of the sine. Okay, so here's the process we're going to go through for every single one of these. First thing we're going to do is find our amplitude every single time. Same process. Amplitude is always the absolute value of A, where A is the number that's multiplying your sine or your cosine. In this case, that's a 3, so absolute value of 3 is just 3. That's going to be my new amplitude. My period, my new period, is always the old period, 2 pi. That's the period of regular old sine and cosine, divided by b. b is the number that's multiplying our variable, x. So 2 pi over 4. Now, maybe I want to reduce that, maybe I don't. I'm going to go ahead and reduce it, but keep in mind, 2 pi over 4 is a perfectly good fraction. There's nothing wrong with it. But I could cancel a 2 out of top and bottom and call that pi over 2. So I'm going to circle both of these. I don't know which one I want to use because I don't know what I want to count by yet. Okay, next we find our phase shift. That's our horizontal shift. That's just a fancy way of saying horizontal shift. And the phase shift is always the opposite of C over B, where C is the number that's added or subtracted inside. Here, I don't have that. There's no plus 7 or something, or plus pi inside. So in this case, C equals 0, so there's no phase shift. I'm going to abbreviate that. No phase shift. Then we find our vertical shift. That's always K. That's the number that's added or subtracted outside. A number that would be out here. Plus 3, plus 1, whatever. There's nothing. Here, K equals 0. So there's no vertical shift. This means that our midline, the thing that goes right through the middle, will be the x-axis, y equals 0. Remember, y equals 0 is the x-axis. Okay, next, we want to find our start and end. And this won't make much sense until we do a few examples, but I want you to get in the habit of always writing this out. Start is always the inside. Whatever's inside the parentheses equals 0. And end is inside equals 2 pi. For sine and cosine, these are always what we use for start and end. So my function that I'm graphing, 3 sine of 4x. When I say inside, I mean inside these parentheses here. So I want 4x equals 0. Exactly. Let me make that prettier. And 4x equals 2 pi. Why 0 and 2 pi? Because we're trying to plot out one period of sine just to get started. And a regular old graph of sine, just regular old sine of x, has a period that starts at 0 and ends at 2 pi. We want to figure out where those points are going to get squished to, or stretched to. So we solve both of these. Here we get x equals 0. If there's no phase shift, this is always going to happen. In fact, start will always equal the phase shift. This is just this is a check right here. Your start and your phase shift will always be the same, even when we get more complicated problems. Here, let's divide both sides by 4 and get x equals 2 pi over 4, which we could reduce to pi over 2. Another check here. End minus start will always equal the period. Because that's what this is. This is a new period. So we should always check that. End minus start. Pi over 2 minus 0 is just pi over 2. Is that the same thing I got for period? It is. Pi over 2. So check. Okay, last thing we got to find is our x scale. And that's always going to be the period over 4. Remember, in each period, we've got 4 important points. The crest, the trough, and the 2 intercepts. So we're going to be labeling all of those. The x scale is how often do we put a little slash mark. And that's always, since every period has 4 important points, we're just cutting the period into quarters. Okay, so here's where mistakes start happening. People not knowing how to work with fractions well. I want pi over 2 over 4. The pi just comes along for the ride. Don't stress about the pi. This is really 1/2 divided by 4, and then we'll tack the pi on at the end. We got to do keep, change, flip here. This is a fraction divided by a fraction. So pi over 2 times 1 over 4. Keep, change to multiply, flip over. That's really 4 over 1, 1/4. My scale was pi over 8. So my recommendation, since we're going to be counting by 8s, let's make all of our fractions look like 8s. So here, when we were looking at our period, it's going to be easier for us if we think of everybody having the same denominator. Let's rewrite this guy as something over 8. So to get 8 on the bottom, I had to multiply the bottom by 4. I'm going to have to do the same on top. Pi over 2 is the same as 4 pi over 8. The pi just came along for the ride. Let's do the same with our start and end. 0 is 0. Pi over 2, same thing as the period here. Let's write that as 4 pi over 8. And then we can just count by 8s and be happy. Okay, we're ready to graph. And the best way to do this, the easiest way I found, is just draw a nice pretty sine wave. There are 2 different approaches you could take here. You could do what's called point plotting, make a big XY chart, plot a whole bunch of points, and then try to draw a nice pretty curve through them. Or you could draw the curve first, and then use the information above to figure out how to label the curve. And I find that second approach easier, so that's how we're going to do it. We're just going to draw a nice pretty sine wave. We're going to draw several cycles here. Because we had no vertical shift, our midline is the x-axis, comes right through the middle. So there's the x-axis. Okay, now we're ready to put on our start and end. We got to think about what sine looks like. I'm going to erase this, but recall, regular old sine of x looks like this. Keeps going forever. Where this is 2 pi, pi over 2, and so forth. This is one period here. This is our main period, you might say. The first period. This is the one we're graphing first. This is my old start. Right there, 0. And that's the old end For regular old sine of x, we want to know where these 2 points ended up. That's what this math was right here, with start and end. We're trying to figure out where those points got stretched or contracted. We want to know where they ended up. So we just pick any spots that look like those. And I got a bunch of choices. I could use maybe this one and this one. Look, that looks like a perfectly good cycle of sine right there. Or I could have picked this one and this one. Sine starts at the bottom and goes up. Look at that. Ooh, that's a perfectly good cycle of sine right there. So I just pick one of those cycles. I drew several. Just erasing that stuff. Let's pick, I don't know, maybe this one right here in the middle. We'll call that our main cycle. So there is my start right there. And here's my end. Right here. Because I know what the graph of sine looks like. If you don't know what the graph of regular old sine looks like, you don't know how to do this. Okay, I know what numbers to put there. Back a little too far. There's my x-axis. I know what to put there because I figured it out. Start is 0, end is 4 pi over 8. So this is 0, and this is 4 pi over 8. Wait a minute, x equals 0 was something special. Recall, x equals 0, that's just another name for the y-axis. That's kind of our goal here. And the more complicated problems, once we get phase shifts in, our goal was to find the y-axis. We just found it. Boom, right there. There's the y-axis. Okay, I know what to count by. Remember, we're always going to be labeling every crest, every trough, and every intercept. And our scale tells us how to label those, what we're counting by. Here we're counting by pi over 8. So starting from 0, there's an intercept. Here's a crest. Here's the next intercept. Here's a trough. That's one period there. 1, 2, 3, 4. Then I'm on to the next period. This guy here goes with the next cycle. And I know what to count by. Pi over 8. So let's just count. Here's 1 pi over 8, 2 pi over 8, 3 pi over 8. Hey, look what's next. 4 pi over 8. There are so many places to catch mistakes that are built right in here. If the next one wasn't right, I'm going 1, 2, 3, and if I'd written 7 here, I would know something was wrong. But look, 1 pi, 2 pi over 8, 3 pi over 8, 4 pi over 8. We could keep going if we wanted to. We could say, okay, there's 5 pi over 8, 6 pi over 8, and so forth. 7 pi over 8. We can keep going as long as we want. I want you to go at least one complete cycle on either side of the y-axis. So let's go backwards. We're counting backwards. -1. Pi over 8, -2, -3, and -4. That's a 4 right there. It's a very ugly 4. Now, don't worry about reducing these fractions. In fact, it's easier to grade if you don't reduce the fractions. Notice how everybody has 8s in the bottom, except 0, of course. So don't worry about reducing fractions. Now, there's one thing we forgot to put in here. That very first thing we found, our amplitude. Our amplitude's supposed to be 3. So that means our maximum height here is going to be at 3, and our minimum will be at -3. And that's a good place to stop.